Hello friends, good morning. In my last few lectures, I have explained three-step distance protection scheme and various schemes for implementation of three-step distance protection scheme. That is by using impedance relays, reactance relay, Moore relay, and combination of these relays. Now let us see what are the drawbacks or limitations of three-step distance protection scheme. Now consider this system. I have shown only two sections for simplicity. Sources are at both the ends. 9 sections A, B, B, C. We are installing relays at both the ends because sources are at both the ends. These are distance relays, so they must have the directional features. If it is Moore relay, no separate directional element is required. And if it is impedance relay or reactance relay, then we have to use separate directional element. So R1, R2, R3, and R4. And these are the settings of relay R1 and R2. For R1, 80% of AB in first step, remaining 20% plus 50% of next section in second step, and then remaining portion in third step. For R2, this is the setting, 80% from R2 end in first step and remaining 20% in second step. Now consider fault in first 20% or last 20%. So if fault is in first 20%, then R1 will operate without any time delay, that is in time T1. Whereas R2 will operate after some time delay, that is in time T1 plus delta T. Similarly, if fault is in last 20 section, R2 will operate without any time delay, whereas R1 will operate after some time delay. But if fault is in mid 60% of the line, then both the relays are operating simultaneously and fault is cleared from both the sides without any intentional time delay, that is in time T1. The first drawback is only mid 60% of the line gets high speed protection, whereas we require high speed protection for entire length of the line. The first drawback is only mid 60% of the line gets high speed protection. Second drawback is if fault is in first 20%, then this circuit breaker will open first and this will open after time T2. It will open in T1, it will operate in T2 time. If fault is in last 20% section, then circuit breaker at this will operate first and after that circuit breaker at R1 will operate. So circuit breakers at both the ends are not operating simultaneously for if the fault is in first 20% or last 20%. It means the circuit breakers at both the ends are operating simultaneously if the fault is in mid 60% of the line. And for improving the transient stability of the system, we need circuit breakers at both the ends should operate simultaneously. So that is second drawback, which is not the which is in the three-step distance protection scheme. So we go for the remedy. Remedy is switch carrier added distance protection scheme. Remedy is carrier added distance protection scheme operating on direction comparison principle. Now I will explain carrier added distance protection scheme. Now let us see what is carrier added distance protection scheme. In carrier added distance protection scheme, carrier signals are nothing but signals of high frequency. Very high frequency signals are the carrier signal. In carrier added distance protection scheme, carrier signals are transmitted from one end to the other end in order to cause simultaneous opening of circuit breakers at both ends. In carrier added distance protection scheme, the carrier signals are transmitted from one end of the line to the other end of the line in order to cause simultaneous tripping of the circuit breakers at both the ends. That is our requirement. We want simultaneous tripping of the circuit breakers at both the ends. So for that, we are taking help of carrier signals. Now, this carrier added distance protection scheme is based on direction comparison. Now, let us see what is this direction comparison principle. So for explaining this, I am considering two parts, F1 and F2. Now F1 and F2, if we observe, both faults are coming in the second step of relay R1. R1 first step, second step. So F1 is coming in the second step of R1, F2 is also coming in the second step of R2. But F1 is internal fault for this R1, whereas F2 is external fault. What is our requirement? Our requirement is, though F1 is coming in the second step, our requirement is it must be transferred in the first step so that circuit breakers at both the ends should operate simultaneously. Whereas if F2 is there, it should remain in the second step. As for this, R3 is acting as primary protection. Now, for explaining the principle, first we have to define local end relay and remote end relay. Local end relay is one which is near to the fault. So, for fault F1, R2 is local end relay. For F2, R3 is local end relay. For F1, R1 is remote end relay. For F2, R4 is remote end relay. So, relay which is near to the fault is called as local end relay, and which is away, that is called as remote end relay. Now for R2. Now in case of this carrier added distance protection scheme, the local end relay sends carrier signal to the remote end relay so as to cause simultaneous tripping of the circuit breakers at both ends. Now this local end relay, how it will differentiate whether it is internal fault or it is external fault. The internal fault is F1 for R2 and F2 is external fault. Now for this, we have to give, or R2 senses the direction of current flow. Now for F1, the direction of current for fault is like this, means it is flowing in the trip direction through R2. But if it is at F2, that is external fault, the direction of current through R2 is in no trip direction. I will repeat. For F1, if we sense the direction of current flow, fault current flow through R2, it is in trip direction. It will start, current will start from generator and it will go like this. So through R2, the current is flowing in the trip direction. But for F2, current will flow like this. So through R2, that is local end relay, the direction of current reverses. So if direction of current to the local end relay is in the trip direction, then local ends relay sends carrier signal to the remote end relay so as to cause the tripping of circuit breaker without any time delay. It means, in general, the direction principle, the local end relay senses the direction of fault current through it. And if the direction of current is in the trip direction, then this sends a carrier signal to the remote end relay so that the first step is extended up to the end of the line and there is simultaneous tripping of circuit breakers at both the ends. Now, depending on how we are implementing this scheme, the carrier added distance schemes are of 4 types. Number 1, carrier transfer, that is called as carrier intertrip scheme. Second is carrier permissive intertrip scheme. Third is carrier acceleration scheme, and fourth is carrier blocking scheme. So in carrier added distance protection scheme, we conclude the local end relay sends carrier signal to the remote end relay in order to cause tripping or blocking of the circuit breaker without any time delay. That is the carrier added distance scheme operating on direction comparison. Now all these 4 schemes I will explain in my next lecture. Friends, if you feel this video lecture useful, then please like it, subscribe to my channel, ask your friends, colleagues and juniors to subscribe to my channel for upcoming video lectures on power system protection and high voltage engineering. If you want to make efficient and effective use of time, then read my book on time management. The link for the book is given in the description box. I have launched a useful course for students on UDEMY. The title of the course is Boost Your Learning and Become Top Achiever. Link for the book is also given in the description box. Course is very useful for the students who are preparing for entrance and competitive exams. Thank you.